So this video will be regarding Chapter 10, Number 9, and Form A. So in this problem, we're given a circle, and there are these two lines through the circle, and they intersect, and we're given the measure of this line is x minus 3, and 3 right there, and x minus 1, and 2 right here. So when I received the Chapter 10 test and looked at it at first, I wasn't sure if this was a chord, if it were a secant, if it were a tangent. I don't know what I was thinking, so we should start by reviewing what they are. So this would be called a tangent line, and it only intersects the circle once. So that would be right there. This is called a secant line, and it intersects the circle right there and right there. And this is a chord, and a chord just goes through the circle, and it doesn't have lines that go out like secants do. So when I went about solving this problem, I didn't know the equation, so I said x minus 3 over 3 equals x minus 1 over 2, and I don't even think that's any sort of equation in this chapter, so I just didn't know. And eventually I ended up with an answer of x equals 3. Not sure how. Okay, but the correct way to go about solving this is to first determine what kind of lines do you have. So the kind of lines we have here in this circle are two chords. And because we have two chords, we can go about with the chord power theorem. So we look at it, two chords, chord power theorem, we determine that, and that is the first step to solving the problem. And the problem asks us to solve for x. So the chord power theorem is, so here's an example of a chord. So let's call this point A, this point B, this point C, this point D, and this point E. So if we were to solve this, and by using the chord power theorem, it would be A times B times BC equals GB times BE. So we can see how this circle correlates with that circle, and by seeing that relationship, we can just use the chord power theorem on the circle given to us on number 9. So we can do x minus 3, because x minus 3 in this case would be like AB. That would be the measure of AB. And that multiply that by 3, which would be the measure of BC, and then x minus 1 times 2, which would be dB times BE. And then to complete solving this, we would just go about a simple algebraic equation. So we would want to start out by distributing these numbers, so 3x minus 9 equals 2x minus 2. So I'm just going to move this up here. And then from there we can just continue to solve, so plus 9 on both sides. 3x equals 2x plus 7, and then minus 2x, and x equals 7. So the answer to this problem is ultimately x equals 7. And that is how you solve a chord power theorem, and that is how you solve Chapter 10, Number 9, Form A.